Hey folks, Quilly18 here, and welcome to another episode of our mostly civilized hex engine for Unity over here. And today we're going to get our little dwarf to move over here. So our dwarf is represented internally in our engine as a unit class, and it also spawns a game object, which is responsible for handling the visual side of the movement and whatnot. What we're going to do here is we're going to keep with that duality, that split. So over here in our unit class, what we want to do is we want to move. So this unit, wherever he is, I want to move him one step to the right when we call do turn. That's going to be what is supposed to happen, okay? So testing, move us one tile to the right. So on do turn, that's what we do. So how do we move one tile to the right? Well, it turns out it's actually a really easy thing to do. What we need is we just need to get the tile one tile to the right and then set that as our new hex. And that's pretty much it. From our internal data point of view, that's literally all that happens. So we want to be able to say something like this. Let's, just for the sake of whatever, we're going to have old hex is equal to hex. Okay? So that we remember that. And then we have new hex, which is equal to, well, here's where it gets a little bit annoying because we need to get hex map. We need to be able to call hex map dot get hex at, where old hex dot q plus 1. So we're just moving one tile to the right, one column to the right, and old hex dot row is exactly the same. That's all we're doing here in the test. On every time do turn gets run, we're going to move one tile to the right. The problem is we don't currently have a reference to hex map. Now, the hex itself has a reference to hex map. It's currently set to private. I think it's probably perfectly fine, and maybe quite an easy way to do it. If we turn this into, actually, let me undo a second here. If we turn this into a public read-only property, public read-only hex map, so this can only be set in the constructor, which is where it gets set over here. And the convenient thing about this is now unit doesn't actually need to find keep a reference to hex map by itself. It can always just get the hex map by saying something like any old hex dot hex map. There we go. So we have the hex, so we can get the hex map from there, and then we can ask for the hex that is over to the right. So we've got the old one, we've got the new one, and really all we're doing with this is we're setting our existing hex to be the new hex over here. Not this way, not this way. That's true. We need to make sure to call set hex. It's very easy for me to make a mistake here with this. Well, I guess it's going to be the way it is, at least for now. So we're going to set new hex as our hex. Because the whole thing is this is going to take care of removing us from the old one and adding us to the new one and that sort of thing. So that's how we're going to move. And the way I'm going to do it is over in hex map over here. Do we have an update? No, we don't have an update function right now. So I'm just going to put in, again, this is just for dummy for testing, void update, something like if input.get key down keycode.space hit space bar to advance to next turn, right? Testing. Just for now. That's going to be perfectly fine behavior. So what we're going to do is if units not equals null for each unit u in units, we're just going to call u.doTurn. That's it. Not very sophisticated, but every unit will then move to the right every time we hit the spacebar. Now, if we were to do that now, this will work-ish, except you won't be able to see anything, right? So we're going to hit over here, spacebar. Ooh, we get an exception. Object reference not set. Oh. When we are spawning our object over here, spawn unit at, we are not actually setting unit.setHex. There we go. So we never actually told the unit what hex it was in when we were spawning it over here. So yeah, let's fix that. Has some invalid arguments. Oh! We're trying to set it to a game object as opposed to the hex itself. There we go. So I'm going to rename this to myHexGeo, just so that there's no confusion again. Okay, so now I hit space. No errors, but nothing is happening. But this should be getting called over here. We could put in a little debug. .log. And now we should see, there we go, do turn is going in. But we don't see anything happening because even though our hex data is getting updated, nothing's happening over on our image. So what we're going to do is we just have to find some way to communicate to the game object that it should move. So what we're going to do here is we're going to go and we're going to create some sort of UnitView script over here. This script's job is going to be to make the unit visual match with the unit data. Now, I don't think we're going to have it do anything in the update. In fact, I don't think we're necessarily going to run a start. We may not, I don't know. But what we want is we're going to want a public function here that says something like unit on unit moved, on unit moved. And it's going to want to know something like hex old hex new hex. Yeah. Animate the unit moving from old hex to new hex. Because in a strategy game like this, the move from one hex to another is instantaneous. You're in this hex, then you're instantly in the other one. But visually, you want it to happen smoothly from one to the other. So how are we going to do that? Well, what we're going to do, it is possible the old hex could be null. We'll have to keep an eye on that, but let's assume the default case is that it's not. Okay, so we've just been told that we are moving from one position to another. So let's go and save that. We actually don't need to save the positions, but or the hexes. What we want to know is old position and a vector 3, new position. So we will need an update. I'm being a derp here, but that's okay. So we want to say, okay, what is the old position? The old position is, hold on. We actually know what the new position is. There's a few things that should happen here. That's actually very interesting. Hold on. Because what does that actually mean? If we have been moved to a new hex, or let me rename this. This game object is supposed to be a child of the hex we are standing in. This ensures that we are in the correct place in the hierarchy. I can never spell this name correctly. That's not right. I think there's missing an R and probably 3 more H's. Hierarchy. There it is. Whoops. Hierarchy. Right, that's what we want. So, and our correct position, our correct world position, when we aren't moving, is to be at 0, 0. Well, sorry. Our correct position when we aren't moving is to be at 0, 0 local position relative to our parent. So that's always going to be our end destination. It's only the reason I'm hesitating here is because it gets me a little tricky if the two hexes are somehow at a border one another and making sure that it animates correctly. So let's make sure of that. But yeah, all right. Yeah, that is actually a little funny. That's fine. Okay, so we will go ahead and grab the old position, new position, although I'm not sure we're going to run it directly. So old hex, we're going to say position from camera. There should be an easier way to do this. I mean, I'm wondering if hex position should be smarter, or if there should be a helper in here. Like something like get hex position. I'm going to rename this to Q and R. And then start off by something like hex H equals get hex at QR. And then just return, because I want this to return a vector 3. I think this will be slightly more convenient. Ish. Yeah. H dot position from camera, because then we can just say something like camera dot main dot transform dot position. What do we have? Num rows, num columns. There's that. And then maybe we'll get another one that actually, oh, that's a good idea. Hex like this. Because then we can actually just return get hex position H. Then we can skip this step. There we go. And then I'm going to do a funny little thing here where you can call position from camera, and what it's going to do, it's going to return the hex map dot get hex position this. So this is just going to call, so from if we call hex dot position from camera, it's going to call hex map dot get hex position, which just then calls the hex dot position from camera with all this data over here. But this data that we don't have access to at this point. So there's a little bit of indirection, but the end result means that over here, we can just call old hex dot position from camera and be perfectly happy. And I think we win a lot in terms of usability. And then this. Now, again, so this would be if these were world positions, but I don't think we actually need that, funnily enough. Because really, so I think we're going to make some code bit changes here, because really what we have in here is an update where we're trying to move to new position. Now, I've in the past, so we want to move smoothly from one to another, right? Which sounds like it might be a place where, well, not a mathf.lerp, but a vector3 .lerp, right? This will move from position A to position B over time. The thing with vector3.lerp is it is linear, so it moves at a constant speed from A to B. When you're doing physical movement, it actually looks a lot better, and I've done weird things with like time.delta times before and whatever, but it turns out there's this other function that I should have been using for ages called smooth damp, which takes a current position and a target position, so this dot transform dot position, and our target position, which is new position here. We're not going to use this as is, but give us a moment. And then it needs two extra values over here, which is a little bit funny. It needs a reference to a vector3 with the current velocity. So we need vector3 current velocity over here. And we have to pass into this function as a reference. That means that this function can actually modify the contents of current velocity. This is just something that it is going to use internally for its own bookkeeping. Okay? Yeah. And then it needs a smooth time, which is the amount of time it'll take to complete this movement. So this could be something configurable. I'm going to say something to start off with, I don't know, 0.5, half a second. Maybe that's too slow, maybe it's too fast, I don't know, but we pass that in there. So what this function will do is it will smoothly move you from position A to position B. And it'll be updating this current velocity internally to keep track of it as a bookmark. It's kind of interesting. And this will return a vector 3 that we just set like this, .transform.position is equal to that. Now, what's the difference between lerping and smooth time? When you do a lerp, you're doing a straight line like this. So when you have like, so this would be, say, time, and this is the position on, whatever axis, but it's the position P. What SmoothNamp does is it does kind of one of these. So the result is at the start of the movement and at the end of the movement, it moves more slowly. So it doesn't start like suddenly goes from 0 to full speed as it does the transfer. It starts slowly, then it hits full speed, and actually hits a little bit higher than the speed that you get in the lerp. And then when it gets close to destination, it slows down. It just makes it nice and smooth. It sort of uses a spring-like kind of thing is the way that it's described. But this should smoothly move us from one spot to the other. Now, I guess we could run this as is. It would run every frame and do this kind of step. There's probably something we could check to say, if you're already there, don't do it. But, presumably SmoothNamp is pretty fast on its own. So our prefab's got that script. So if we do hit play, nothing should happen because old position, new position, right, both get set to 0. So our dwarf actually is moving in half a second from one position, from its current position to that. So I guess what we'll want to do is we're going to want to reset at start and just set old position equals new position equals this .transform.position. There we go. All right, there we go. So now the dwarf's not going to move. What I could do is I could actually set new position to be equal to this .transform.position plus vector 3.right. So that's just going to be +1 in the x. And if we hit play, there you go. You can see the dwarf has moved over from one to the other. Probably we'll want it faster. That feels to me it might be a little sluggish, but we'll see how it goes. Okay, so just confirm that there is a smooth move from one to the other. Now this I'm not super keen on, but let's get back to it over here. So unit moved. On unit moved, we want this called when a unit moves from one hex to the other. So what I want is for the unit itself, right? It's going to move. It's going to change its position over here. What I want is I'm going to want an event listener. Public event. You do still have to use a public keyword. I'm sure you must. Public event. Which is, I guess we're going to have to define a delegate first, yeah? Probably. Okay, so we've done a proper tutorial for this before. Just as a little recap, what the hell are we doing here? Basically, one thing you have to remember, and it's a lot of people don't think about it this way, that in a sense, your functions themselves, your methods here, are sort of values being stored in a variable. There is effectively a variable named setHex that points to a function. And it just so happens that when you call something like setHex and then you put the parentheses over here, it calls the content of that function. But in a sense, what you can do is you could assume that setHex is something that you could set to another function of some kind. And this is actually something that's entirely possible to do. So functions, these function names are just variables that point to content, but instead of holding a string or instead of holding an integer or something like that, they hold function data. So what a delegate determines or just describes the signature of a function. So we're going to want to describe the signature. I don't think this actually even needs to be public, honestly. But we're going to describe a signature for a function that's going to be notified when a unit changes from one hex to another. So this is going to be a function that is expected to return nothing. We'll call this something like hex or unit moved delegate is just going to be the name of this delegate. And the signature for this is going to be something like hex, old hex, hex, new hex. So this is not a function. We're simply what am I? Oh, you know what helps a lot is if you spell things correctly. Hooray! There we go. Okay. So that's it. And again, I don't even think we need this to be public. I'll just do this. The reason we have to do this is because when we set up an event listener, it expects a delegate name. We have in the past I've made great use of like the action, which is a templated. You need to include using system to use that, action and func, which is just a short form or generic form to do delegates, but we're going to go ahead with this. So what we're going to do here is we're going to have an event. So this will be a public event and it's going to be a unit moved delegate type event. And we're going to call this on unit moved over here. And the important thing is when our hex change, when we change from one hex to another, we're probably going to want to call on unit moved. I'm not 100% sure that's true, that we're going to want to do it within set hex, because there may be situations where someone is supposed to, I don't know, maybe they've been airlifted or something like that. So that's not an on unit moved exactly, that should be animated, but you know what, for the sake of argument, it's going to be fine. So if on unit moved is not equal to null, then what we're going to do at this point is we're going to call on a unit moved. So this is a variable that's going to hold one or more functions, which will all get called when this happens. We're going to talk about this event keyword in a second, okay? For now, like in a sense, we could actually get rid of this. We could actually totally get rid of the event keyword right now. We're going to talk about what it does in just a moment. So then what we can do is in our unit view over here, or not here, when we create the unit view, okay, and we get our unit game object, and our unit game object has a component called unit view. There we go. Get component unit view, and it has this function that is expected to be called when a unit moves. Well, what we can do for our hex, okay, let's actually grab our hex here. Hold on. Hex, my hex is equal to this. Then we can say my hex and my hex, because we're going to have to do more. Okay. So we can say, listen, my hex has a... No, sorry. Unit has a on unit moved event handler. We're going to register this. Units on unit moved handler, we're going to add to this list on unit moved. So this is effectively, it's like a list. It's like an array. We can set it. We could just do a set. This will override whatever's in there. But what we're doing is we're adding ourselves to the list of things to get called when this unit moves. So then when this line here, when on unit moved gets called, it's going to call the function that belongs to my unit view over here. Now, what does that event keyword do? The event keyword just makes it so you know how this right here, unit move delegate, is public? That means that anyone anywhere could do something like this. Okay, if we go and tab out, make sure it compiles okay. Apparently this does have to be public. Oh, right, because this describes the signature of this callback, so everyone else needs to know what this looks like. So we make the delegate public. Let's try that again. Oh, it needs a pair of hexes. When you call OnMove, that's true. It needs a couple of hexes. This is just temp. We're getting rid of this in a second. This is just, I'm going to just be proving or demonstrating something. But yeah, OnUnitMoved here, we're going to do something like if hex not equals hex remove. Okay, so we need to keep track of old hex equals hex, hex, new hex equals to the lower one. Actually, we'll just call this new hex. Like that. So we save the old one, because then what we can do is call old hex, new hex over here. Does that get rid of all the errors? Name hex is on include. There we go. Okay, finally no errors. Ignore this warning, that's going to be fine. So right now, when we have, sorry that took a few extra steps. If this OnMoved over here is just a public, that means that we can call it here. We can force the OnUnitMoved event to fire. If we change this to add the event keyword, this becomes what I describe as sort of semi-public. We're still allowed to do this. We're still allowed to add to this event listener. We're allowed to register new functions that will get fired, that will get called when this event fires. But this line all of a sudden becomes illegal. Boom. Error. The event unit.onUnitMoved can only appear on the left-hand side of a plus equals or minus equals when used outside of the type unit. So the only thing we're allowed to do, because this is an event, the only thing we're allowed to do is register something to it with a plus equal or remove something from it. Both of these are illegal. We actually aren't allowed to just do an equal assignation here or assignment, which would wipe away whatever was previously in there. By using that unit keyword, the only two things we're allowed to do to unit.onUnitMoved are these two lines. Outside of the unit class itself. Inside of the unit class, we can still do whatever the hell we want. But there we go. So now, anything can register as a listener for the OnUnitMoved event. And the OnUnitMoved event will currently get called within set hex. We may want to change that later. And it will call the old hex and the new hex. So now, if we go back over here, the error should go away. We hit play. Now, in theory, if I hit plus, there we go. Our unit is slowly moving. I mean, always one unit to the right, because that's what we had plugged in there. But we are now smoothly animating from one to the other. Okay, I was going to say, when we get to the edge of the map, though, something slightly odd will happen. Right? And odd and not entirely... no, I don't want to zoom out there. I want to zoom out this view. So let me do this again. Zoom out a little bit more. Okay. All right, what's going to happen is as soon as it hits the edge of the map, it's going to the next tile on the right, which is actually wrapped on the left, which means we're going to hit space, vroom! He's going to take a half a second to teleport to the other side of the map, which is not very appealing. So we're really going to want to make some sort of check there to make sure that we're not on the edge. And just at first blush, I'm not exactly sure how that should be handled. You know, I suppose it could be something as simple as if vector3 dot distance from old position to new position is greater than some sort of like threshold, which honestly is probably just like greater than 1, but let's say greater than 2. Okay, greater than some value, then this is quite the hop. This OnUnitMoved is considerably more than the expected move between two adjacent tiles, which is always going to happen, even with something that's got a movement speed of, say, 2 or 3 or 4, right? Like, so you got a cavalry unit that can move 4 tiles. It still moves 1 tile at a time. It doesn't teleport from one to the other. It follows some sort of path with its 4 movements, right? And the on unit moved is actually going to be doing this one at a time. It's going to call the first move, the second move, the third move, the fourth move is the idea in kind of a queue over here. So this is considerably more than the expected move between 2 adjacent tiles. It's probably a map seam thing. So just teleport. So what we're going to do is we're just instantly going to set old position is equal to new position. I mean, we don't actually use old position. Old position is just where we were. So we can just do something like that and like that. That's totally okay. But what we want to do is set this.transform.position is instantly equal to the new position is what we want to do. So if our current position is bigger than 2, then we just got to teleport or something, and that will get rid of that. So it's still not all the way there because we're going to have to deal with the incremental bits. Oh, there is some interesting stuff here. You go and teleport there, but if I was double tapping, it was getting a little bit funky. You know what we should do, actually? That makes a lot of sense. We should always set, in this phase, old position is equal to this, and we should reset the current velocity equals vector3.0 so that any old sliding is gone. So every time you move to a new hex, so if I hit twice, it'll jump to the... So what I'm going to do is I'm going to hit it once, so it's going to start sliding towards the mountain, but then I'm instantly going to hit it again. So what's going to happen is our old position is just going to get... Our current position is going to instantly teleport to the correct place for the mountain, and then it'll start to drift over to the forest. See? And then more importantly, if I get to the edge, you just teleport to the other side because it's too far over. And that's, I think, very desirable for this. So the trick will be that on-unit move will have to be called sort of like appropriately periodically here, right? If there's a whole series of them, maybe there's going to be a queue. We'll figure that out. But we've got a little bit of smooth movement for now. That brings us to the end of today's video. Thank you very much for watching, folks, and I'll see you guys next time. Hey, I want to say a great big thank you to all the June Patreon supporters and these Mic Check supporters. We've got Yukofin, Eric Sumner, Tiburon, Mighty Mix, Pavel Zdanov, Drazion, Michael McClintock, Aaron Toyson, Craig Mortel, The Not So Evil Engineer, Julien Auger-Lafont, Marius Fieldvold, Speedy Savant, Valiant Cakeveen, Thomas Oberson, Jason Yanity, Stephen Bonnerman, Kale the Quick, and Neil Blakey Milner, and absolutely everyone who watches, shares, favorites, and subscribes to these videos. Thank you so, so much.